control systems. The topics to be covered in this session: general system equation, zero order system equation, first order system equation, second order system equation. Generalized system equation. It's an nth order equation. Xi is an input quantity fed to an instrument and X0 is an output quantity. It's a generalized block diagram of an instrument. The generalized system equation related to this instrument is an nth order equation. It is an b raised to the power n, an minus 1, bn minus 1 plus and so on plus a1 b1 plus a0 b0 of x0. X0 is an output quantity. It is an output side equation. bm dm plus bm minus 1 dm minus 1 plus and so on plus b1 b raised to the power 1 plus b0 b0 of xi. It's an input side equation. Generalized system equation which relates the output quantity and the input quantity. So this is the generalized system equation. The order of this system equation is n. It's an nth order instrument. It is an equation, nth order system equation. In this equation, A's and B's are combination of a system physical parameters and it is assumed to be a constant. Based on the order of the system equation, the instrument may be classified into zero order instrument, first order instrument, second order instrument, third order, fourth order. The third, fourth and all other order instruments are collectively called as higher order instruments. So in this session, we will look into zero order, first order and second order instruments. Dynamic response of a zero order instrument. Zero order instrument. The order of the system equation is 0, b raised to the power 0. In that instrument is known as zero order instrument. It is a generalized system equation given. In this equation, all the A's and B's, that is the coefficient of D, are taken as 0 except A0 and B0. A0 and B0, except these two coefficients, all other coefficients are taken as 0, get cancelled. Now we will get an equation A0 D0 of x0 is equal to B0 D0 of xi. We know the equation to be rearranged. A0 x0 is equal to B0 xi. x0 by xi is equal to b0 by a0. So x0 is the output quantity, xi is the input quantity and b0 by a0. x0 by xi is equal to b0 by a0 is equal to k. This is called as zero order system equation and k is known as static sensitivity. Example for zero order instrument is potentiometer. While writing a mathematical modeling of a potentiometer, it is equivalent to that of the equation x0 by xi is equal to b0 by a0. Dynamic response of a first order system. The order of the system equation is 1, then that instrument is known as first order instrument. Starting with the generalized system equation, all the coefficients are taken as 0. All A's and B's are taken as 0 except A1, A0 and B0. Except these coefficients, all are taken as 0, get cancelled. Now we have an equation, simplified equation, A1 B1 plus A0 B0 of x0 is equal to B0 B0 and xi. So here in this equation, rearranging x0 by xi is equal to b0 d0 by a1 d1 plus a0 d0. B raised to the power 0 the value will be 1. Again simplifying that, we will get x naught by xi is equal to b naught over a1d plus a naught. Again, divide the numerator and the denominator by a naught. b naught by a naught over a1 by a naught d plus a naught by a naught. This will get cancelled. Now the equation becomes x naught by xi is equal to b naught by a naught divided by a1 by a naught d plus 1. And next what we have to do is, we have to substitute for this coefficient b naught by a naught and a1 by a naught. So b naught by a naught we already derived from zero order instrument. This is equal to k. And a1 by a naught taken as tau and constant. So substituting in this equation, x naught by xi is equal to k divided by tau d plus 1. This equation is known as first order system equation. A is the static sensitivity and tau is a time constant. The order of B is 1. That's why this is called as a first order instrument. B naught by A naught is equal to K, static sensitivity. A1 by A naught is equal to tau, time constant. The example for first order instrument, RC filter, low pass filter or the high pass filter. Dynamic response of a second order system. The second order instrument, the order of the system equation is 2. Then that equation is known as the second order equation. A system which is associated with this equation is known as a second order system. Sorry for the generalized system equation, all the coefficients are taken as 0 except A2, A1, A0 and B0. All other coefficients get cancelled because of 0. Now we will have an equation A2 d raised to the power 2 plus A1 d1 plus A0 d0 of x0 is equal to b0 d0 xi. Rearranging this equation, we will have x0 by xi is equal to b0 d0 divided by A2 d2 plus A1 d1 plus A0 d0. The value of b raised to the power 0 will be 1. Simplifying that, we will get b0 by A2 d2 plus A1 d plus A0. For making the coefficient of b2 as 1, we have to divide this equation by A2. Now, we will have an equation b0 by A2 divided by A2 by A2 d square plus A1 by A2 d plus A0 by A2. A2 by A2 1. We have to substitute the coefficient B0 by A2, A1 by A2 and A0 by A2 by some other constant. B0 by A2 is equal to A0 by A2 is equal to omega n square. A1 by A2 is equal to 2 zeta omega n, and these two constant to be introduced for this. For B0 by A2, substituting omega n square and A0 by A2 omega n square, and for A1 by A2 2 zeta omega n. Now this equation x0 by xi is equal to omega n square divided by d square plus 2 zeta omega n d plus omega n square. This equation is second order system equation. The order of this equation is 2. Here b0 by a2 is equal to a0 by a2 is equal to omega n square. It is a natural frequency. a1 by a2 is equal to 2 zeta omega n. Zeta, it is a damping ratio. Example. Spring balance is the right example for second order instrument. RLC circuit, it is an example for second order instrument. Electrostatic to an electromagnetic conversion in second order system. Moving coil indicator, electromagnetic recorder, these are all the example. Now we have to test our our knowledge what we learned in this session. First question. The order of the system equation is 0. Then that instrument is known as zero order instrument. Second question. The order of the system equation is 1. Then that instrument is known as first order instrument. Next question. The order of the system equation is 2. Then that instrument is known as second order instrument. Name the system of the system equation given. The system equation given is x naught by xi is equal to omega n square divided by b square plus 2 zeta omega n d plus omega n square. The order of this equation, differential equation is 2. Then it is second order system. Name the system of the system equation given x naught by xi is equal to k tau d plus 1. So order of the system equation is 1, d raised to the power 1. So this system is first order system. Name the system from the system equation given x naught by xi is equal to b naught by a naught is equal to k. The order of the system equation is 0. So that's why this is called as a zero order system. The keywords associated in this session: the order of the system, zero order system, first order system, second order system, and the system equation. Thank you all.